So here I have a couple of logic circuits. I'm gonna explain all of them. So yeah. So the first one here is the I/O circuit, or the yes circuit. Basically, the output equals the input. If the lever's on, the lamp is on. The lever's off, the lamp is off. So this is probably the easiest redstone circuit you can make, and I don't know if that's even considered redstone. But yeah. Here's the next one. It's the not circuit. And that wavy line right there, that's a symbol for a not. So here, look. If the lever is on, the lamp is off. The lever is off. Oh, yeah. The lever is off, the lamp is on. So here's how it works. The torch turns off if it gets powered, and it makes power if it isn't getting powered or if it's turned on. So there it is. Now here is the inclusive OR. So inclusive means that it includes something. And here an inclusive OR includes if both of them are on. And it does not turn on if both of these are off, but if one or the other is turned on, then it would also turn on. So there's the inclusive OR. It's just two of the levers pointed into the redstone lamp. So here's the next one. It's an AND. It's the same thing. Oh yeah, the first one's the AND. And here, look, if both of them are on, the lamp turns on. If one of them or both of them are off, then it will turn off. So it's the same thing as not A or not B. And here how it works. Yeah. And well, it's really complicated because well, the levers in Minecraft, they actually make power instead of letting power go through. And here we can use the De Morgan's law to turn I think it was ORs into an AND, ORs and NOTs into an AND. And here, so here we pretty much kind of knotted everything. Well, kind of. And here, so look, if one of them is on, it depowers the torch, which makes that not give any power. Except this is still getting powered by that torch. There. The redstone here is it's an OR. And then it combines the two outputs. It combines the two outputs. Yeah, the two inputs, not the outputs. But yeah, it combines the two inputs, and yeah, the redstone there is an OR, and it combines the two inputs, and there is also the torch here. That makes it not, because that wasn't there. Because if that other knot wasn't there, then it would be the opposite of an AND. There it is. Both of them are on. It goes through that. And well, yeah, that's the AND. And here I actually made a double AND. So we got another AND here. We can turn that on to get that. And you don't actually need the repeaters for an AND. We just use the repeaters to hard power it to go through this one and get another AND to the final output. So, now here is the next one. This is one that I was just kind of messing around with, and it's an AND or a NAND. So yeah, here's the AND that we used from the previous one. the OR is this area right here. And this is a NAND. A NAND is a not AND. It's everything except an AND. So here, that's an AND, but yeah, here, this is an AND. Right now, this situation, if it was an AND, it would turn on. But here, look, it's everything except an AND. Because there isn't a NOT here. It's just redstone. So yeah, there's the OR. And we can turn it back off. And yeah, here is the AND. We can also make that go to power the lamp. We also wrote down all the combinations. There's 16 combinations, and only 2 of them make it go off. So those are all the combinations. Like only 0, 1, 1, 1 makes it go off. Oh, yeah, 0, 1, 1, 1, that's off. And also 0, 0, 1, 1. That also makes it go off. So now we can go over to the next one. Yeah. Okay. So here's the NOR. So it's a NOT OR. So here, look, it's in the OR state right now. And here is the other OR state. They're also off. But look, if it isn't an OR state, then it's like that. Then the redstone lamp gets power. And here for the NOR, it looks like there's just a NOT there. Then it goes over to the lamp. Okay. Now, here is an XOR. It's an exclusive OR. And an exclusive OR means that it excludes one. It excludes both of them being in there. So, yeah, both of the levers being gone. But yeah, an XOR is basically like a difference detector. So if one of them's on, it goes like that. But if they're the same, like that, or like that, then it's like that. Then the redstone lamp turns off. So it is pretty much a difference detector. Okay. So now here is here is another example of an XOR. It's just a little bit more compact. And yeah, an XOR can also be good for addition and light switches. Yeah, there's another XOR. There's actually a redstone in the middle there, but okay. Yeah, here is an XNOR, and it's like a sameness detector. Yeah, and the XNOR is kind of like a sameness detector. So look, an XNOR is it kind of has a knot at the end there. Yeah, look, it's a sameness detector. If both of them are off, turns on. If both of them are on, turns off. If both of them are on, it turns on. And now here is another XOR. It's even more compact. Yeah. And these are comparators in subtract mode. So, there are all of those ones. And now we got another one from using two of those other. First I can explain what it is. It's a binary half adder. So it's like a binary adder, pretty much. If it's a 0 plus 0, it's like this. Then it's a 0, 0. And 1 is on and 0 is off. And here, if it's a 0 plus 1 or 1 plus 0, it is a 0, 1. Yeah, it's just a 1. And then if it's a 1 plus 1, in binary it looks like a 10, but Yeah, 1 plus 1 is like a 2. Yeah, here is the half adder. Look. 1 plus 0, 1. 1 plus, yeah, that is a 0 plus 1. Here's another 1 plus 0. It's also a 1. 0 plus 0 is 0, 0. And 1 and 1 is a 2, or yeah, 1, 0. Now how I made it go like this is here that we combined an XOR, which is like the adder, with an AND. The AND detects if both of them are on, and it does the carry, and the XOR makes it turn off. If it's like this, then the XOR makes it turn on. Both of them aren't on, so it doesn't go through the AND. And it's the same like that with the other one. So there's the carry output and there's the adding output. So yeah. So yeah, there is all of the logic circuits that I've made. Okay.